Welcome everyone. So in this video, we're going to talk about what it means to quote unquote completely factor an expression. So I have this quadratic expression 5x squared plus 15x minus 20. So if I had this problem just at the end of the previous video, I would just factor it like so. So I'll start off with my sum. So again, this is my sum. I'll start off by putting my x squared term in one corner. So I like to put it in the top left. Put the negative 20 in the bottom, in the opposite corner, so the bottom right in this case. And I need to find out what these two missing boxes are. Those two missing boxes are going to have to be two numbers that add up to 15, because those are going to be my x terms. And they have to multiply to the whatever the opposite diagonal multiplies to. So in this case, 5x squared times negative 20 is going to multiply to negative 100 x squared. So that's going to be 5 times negative 20 is negative 100. Excuse me. So I need to figure out two numbers that multiply to negative 100 and add to 15. I believe our answer here, and you want to check my work here, I believe the numbers we're looking for are 20 and negative 5. So more specifically, negative 20x and negative 5x. So I'm going to put that right here. 20x negative 5x. Alrighty, so now that I've done that, I can pull out my common factors, and there's actually several ways you could do this. Alrighty, so for example, one way, and I'll do this in purple across the top and on the left side, is that I could pull out, let's see, a 20 right here, because 20 is a common factor of 20x and negative 20. That would mean that this side here has to be negative 1. Let's see, last part here, this has to be an x to form 20x across this row and column. And that would mean that this top left side length here has to be 5x, I believe. So one way to factor this is to write it as 5x plus 20 times x minus 1. Okay. Alternatively, I could have looked at it like so. So I could have started off right here. I'm going to do this in a different color, green, and said, okay, well, a common factor of 5x and 20 is, it's 5x squared and 20x is 5x. Okay, if that's the case, then, that's 5x, then this side right here has to be 1x, because 5x times x is going to get me to x squared. Okay. Let's continue on. So if that's 5x there, then this side has to be 4, because 4 times 5x gets me to 20x. And this last side right here has to be negative, I believe, negative 5. So that would mean that my factored form now, if I'm going about this green method, would be 5x minus 5 times x plus 4. Huh. Well, so which one is correct? Well, unless I messed up some of my process, I believe they're both correct. And again, the way to check if your factored form is correct, and I'll write that right here, product, is to take it and multiply it back out. Right, and I believe that actually will work. So the question is, why do we get two different answers? Well, in actuality, they really are the same answer, because what we can do is check this out. Notice inside 5x and 20, those two terms right there actually have their own common factor, and it's 5. So what I can do is we say factor out the 5, and what's left over would be x plus 4. And then this piece is untouched, so we just leave it as x minus 1. If we look at the green one, I could do something similar, where this 5x minus 5 has a common factor as well, which happens to also be 5. And now I have x minus 1, and again, the x plus 4 is untouched. And we see now we actually have the exact same thing. If you don't believe me, we should maybe reorder them, because the order of multiplication does not matter. So I can write it like so: 5x minus 1, x plus 4 is indeed equal to 5 times x minus 1 times x plus 4. Okay, this has been now completely factored, and we say completely factored because, these two on the top row were not completely factored because we were able to pull the 5 out. We could pull out a common factor. an integer common factor. Now, you could always pull out more. So, for example, I could pull out like a 1/2 and then call it x over 2 minus 1/2, or minus 2. But we're really dealing with integer coefficients here, whole number coefficients. And so completely factored means that you're going to pull everything out as much as possible. Now, we could have done this from the very, very beginning, because we notice that in the starting sum, 5x squared, 15x, and 20 all have a common factor of 5. And so from the very beginning, we could have started off just like this. 5x squared plus 15x minus 20, that's equal to 5. And whatever's left over, remember, when you multiply or distribute it back, you should get back to what you started with. So let's see, 5 times what gets me to x squared? Oh, that's 5 times x squared. 5 times what gets me to 15x? That's going to be 3x. 5 times what gets me to negative 20? That's going to be negative 4. And now you could simply factor this. And notice this, the numbers inside here are actually much smaller than what they were before if we did not factor the 5 out. And so this actually usually makes it a little bit easier. But I won't go through the whole process in this video, but you should confirm that when you factor this quadratic inside the parentheses, now you'll end up with x minus 1 and x plus 4. So whenever you are asked to factor a quadratic, or really any kind of expression, always, step 0 even, is to look for common factors that you could extract out of that expression first. Alrighty, thanks for watching, and I hope this helped.